morning, Cedric.
Oh, hi, Jean.
I find it so difficult these days. Yesterday was hot, today it's cold. How am I supposed to know what to wear in the morning?
Same for me. I think the cause is the climate change.
Climate change, climate change. Everybody's talking about climate change. I'm not even sure to know what's causing it.
Oh, that's the greenhouse gases.
Greenhouse gases like CO2 and methane?
I'm not an expert, but from what I know, both of them are the most studied gases by the scientists. So I believe that both of them are the most impactful on the environment.
So they would be like the more dangerous?
I believe so.
Maybe we should make it clearer and look on the internet.
Yeah, why not?
Okay. Hello, fellow young scientists. My name is Professor Dirzu, and this is Professor LaBerge. Today, we will talk about greenhouse gases. More precisely, we will discuss the factors that influence the importance of greenhouse gases on the environment.
So, the first factor that we'll talk about is their abundance. In other words, their quantity in the atmosphere. Secondly, we'll talk about their lifetime, so how much time they spend in the atmosphere. And to conclude, we'll talk about their capacity to absorb infrared radiations. Let's start with the first factor, the abundance. To begin, we'll only talk about three greenhouse gases, which are the three more important ones. We have carbon dioxide, methane, and nitrous oxide. As I said earlier, human activities play an important role in the emissions of greenhouse gases. Indeed, firstly, carbon dioxide represents 81.6% of the emissions by human activities due to combustion of fuel and electricity. Secondly, methane represents 10% due to agriculture. And to finish, nitrous oxide represents 6% due to residential use, such as food residue and electricity.
So now, let's talk about the lifetime of greenhouse gases. So what is the lifetime? Is how many years could last a greenhouse gas in the atmosphere. So here we have three molecules, which are the three principal greenhouse gases. So the first one, we have carbon dioxide that lasts around 100 and 200 years. We have methane that lasts approximately 12 years, and we have nitrous oxide that lasts around 114 years. After this amount of years, those gases become less and less harmful for the environment. So now, let's continue with the absorption of IR radiations.
Now, follow me. What is ER radiations? Obviously, it's a radiation, which means that it's a form of energy, composed of a wavelength and a frequency. Secondly, it's part of the electromagnetic spectrum. Here you have a sequence of the spectrum. You have the UV light, then the visible colors from violet to red, and then you have the ER radiations from a wavelength of 1 micrometers to a wavelength of 1 millimeters. Let's move on with the two conditions. Let's not forget that we're talking about the third factor, which is the capacity for a molecule to absorb ER radiations or ER energy. In order for a molecule to absorb energy coming from the Earth's surface, it has to satisfy two fundamental conditions. Firstly, the radiation energy must match the energy of the molecular transition. In other words, when a certain molecule is subject to radiation, their electrons and nucleuses are moving, and those movements create energy. If this created energy is comparable to the energy of the radiation, the molecule will absorb the radiation. Note that the molecule must be polyatomic in order to have a displace of its component. I want you to think about it. If the molecule is composed of only one atom, the displace of its component would only mean the movement of the whole molecule. Let's move on with the second condition. it is necessary that the change of electric field touches the dipole moment of the molecule. I'll use the CO2 molecule to explain. The charge distribution between carbon and oxygen is not evenly distributed, since oxygen is more electronegative than carbon. Thus, CO2 is a polar molecule and has a large dipole moment. The dipole moment is determined by the magnitude of the charge difference and the distance between the positive center and the two negative centers. Because the molecule vibrates, its dipole moment changes. This causes the apparition of a field that interacts with the electric field connected to the radiation. ER absorption occurs when the rotation of asymmetric molecules around their centers, such as carbon dioxide, results in a dipole moment change that will create an interaction with the radiation field. I may talk a lot about CO2, but methane has the ability to absorb 30 times more AR radiations than carbon dioxide, which makes it the most efficient molecule of the greenhouse gases. Nevertheless, it may be the more efficient one, but it doesn't mean that it is the most harmful.
So in the end, we can't really say which greenhouse gas is worse than the others.
No, because there's too many factors to consider.
Like CO2 is more present in our atmosphere.
Or methane absorbs more radiation than CO2.
Given that there's not necessarily a factor more important than the other, we can't really say which greenhouse gases is the worst. The only thing we can really say is that nitrous oxide, methane, and CO2 are the most dangerous ones due to their lifetime, abundance in our atmosphere, and their capacity to absorb ER radiations.
So finally, the most important thing we can do is try to reduce the emission of greenhouse gases.
That would help me choose my clothes in the morning.